Okay, so continuing on our similar shapes, I've drawn two very artistic similar shapes here. You can just see from where you're sitting, these are perfectly similar. Obviously, just a little joke there. There should be something written like not according to scale. But anyway, the point is these are similar shapes and they're giving us a type of a radius or a length in these, I don't know what these things are, raindrops or something. And they're asking for the volume, not the volume, the area. Let's make this the unknown, which is x. So what I'll usually do is I'll just start with what I can compare. Now I can't compare the volume, the areas, because they are not, I can't use this to find the scale factor because one value is known and the other one's not known, but I can use the lengths. So I'll use the bigger number over the smaller number. And this is now my length scale factor because I'm using in lengths, right? So these might be centimeters, well, it's probably centimeters. So this is my length scale factor. Now I can use it like this, just the 10.25 over 4.1. But if I were to put that on my calculator, I'll get a nice round number like 2.5. But you won't always get a nice number. So using this fraction, whether it's nice or not, or the 2.5, it makes no difference. The very important thing to realize is this is the length one. And we want to compare areas. So I know if length increases, then area increases kind of even more. So I need to find my area scale factor. So to get an area scale factor, again, this is not a term I think is recognized anywhere. I'm just writing this as area scale factor. I will have to square this. So 2.5 squared. And again, I can just use it like that in my calculator, or I can write it, and this is 6.25 or 25 over 4. These are all the same. Whether I use 2.5 squared, 6.25, or 25 over 4, it doesn't matter. Now, the next step would be to write down what they gave me. So I write the 40, and usually I write kind of the scale factor that I'm going to use. In this case, it's 2.5 squared, and I know that's going to give me x. But now I just have to decide, am I going to multiply or divide? And that's just the question saying, well, I'm going from a bigger shape to a smaller shape, so I will have to divide. And you can just type that in your calculator. So 40 divided by 2.5 squared, that would give me 6.4. So x is 6.4. So that's fairly straightforward. Let's say these are, just to make our, just continue on this. Let's say these are prisms and this is the area, and they're like kind of pipes that go in that direction. And let's say we have a volume of, what am I going to make it? Let's make it a weird number, 762 cubic. Or let's do that for this. Let's say that's for the small one. So let's say the small shape has a 762 cubic centimeter volume, and we have to find the bigger one. Now I'm going to take this out because we don't need this anymore. Well, we do need the length one. So let's just take this out and say, well, let's say the question is just this, saying, hey, this is the volume for this shape. Obviously, it's not drawn in 3D, and we want to find the volume of the bigger shape. So what can I compare? Again, I can use 10.25 over 4.1. And in this case, I'm not even going to make it smaller. I'm just going to keep it like that. And the question is, if I'm comparing volumes, I have a length scale factor. But I want to compare volumes now. So I can't use area, but I have to go to volume. So I have to go all the way up. So this scale factor that I have here, I have to cube it. And whether I write that or 2.5 cubed, it doesn't matter. Your calculator will accept both, and it doesn't matter. The point is just you have to realize that the length scale factor, which is inside the bracket, can't be used for volume. Just as it is, you have to cube it. So once this is cubed, I will take that number, 762, and I'll decide, well, I'm going from a small shape to a big shape. So anytime I go from small to big, I'm gonna multiply. And I'm just gonna multiply by this scale factor, which is 2.5 cubed. And I'm gonna put that in my calculator, 762 multiplied by 2.5. Where's the cubed? Cubed. And then I get a very big number like 11906.25, and the units would be cubic centimeters. So in this video and the previous one, we looked at using length and going to area, and using length going to volume like we just did. In the next video, we're going to see what happens when they give us volume or area and we want to go to length.